So we're going to be working with our geometric means again and working more with our geometric sequences in series. Just as a little kind of note on things that I put in grade books over the weekend, I got our quizzes in. Also, if you have all the quizzes, like finished, like you don't have anything missing, I also dropped your lowest quiz score.
Yay!
So, like those of us that have any missing quizzes, we need to make those up so I can do that for you. But those of us that have all of our quizzes in have their quiz score dropped, and it's marked in Canvas and it's marked in Skyward which one would be dropped. If you want to know specifically which quiz it was, I can let you know yours. And it also has in the comments what your original score was so you can see it. So those are put in. We have that kind of working together. We don't have any more quizzes after this. If we're not super happy with our quiz grade, the project that we're going to do for the, like, in between this chapter and when we start reviewing for finals, that will go in into the quiz category. So it can boost that section up score-wise. Because some of us need a little boost in there. That's okay. We'll be fine.
Can you switch it and like divide it by 2 and then like give me those points for a second?
No. But if you do better on the final than you did on one of those previous tests, it will replace the lowest test.
That's not happening.
Your 50 gets to go away.
Okay.
What did she say?
I don't know.
What did you say?
So let's look at this one up here because we have a little bit left to go in this chapter. We're going to find our geometric means, and then we're going to get into some sums and do stuff like that.
I did not see that. You need to stop. You need to stop.
I'm going to keep them tethered together because they're being very grumpy about talking. So they're stuck together with the get-along shirt, basically. It's the cables. So I'm going to be here for a little bit until I'm confident that they're talking. They did. And now it's kind of like little siblings in a get-along t-shirt where you put them in the... All right. So when we're trying to find the geometric mean or insert any number of geometric means, what we're looking to do is we're looking to take our sequence that has a 3 and a 4, and we're trying to squeeze something in. We usually call it C, or C1, or however many we've got, just out of habit. That would make this be a geometric sequence. That is really big. I am going to shrink it. Move that just a little bit. I don't know if it'll let me shrink it. Nope. Not in one chunk. Just because that felt really big. There we go. So we want this to be a geometric sequence, meaning it multiplies evenly between them. So we're going to need a couple of our formulas from last week. Thinking about our a sub n that we get from our a sub k times our common ratio to the power of n minus k. That's one of them. We could also use our common ratio that we get from our a sub k plus 1 over a sub k. They have to be neighboring terms for us to use our common ratio formula like this. So it would have to be naturally. I think my iPad's just like done because it did. I think it probably just needs to restart. So since these guys are not neighboring pieces, I can't use my common ratio thing. We're going to use this piece to find our ratio, which means we need to know what number terms we have here. So I'm going to number them up so we know. This is our first term, so we're going to have our A1. This is our second term, so we call this A2. This one's our third term, so we call it A3. So the only ones we know values for are our third term and our first one. We're trying to figure out what C is. So I'm going to use this guy up here, and I'm going to have my n be the 3. You don't have to. If you want to have that be 1, that's totally fine. I just tend to do the bigger one as the n, so we do not wind up with a negative exponent. It's the only reason I picked that. It's not wrong to go the other way. It's just going to give you harder things. So I'm going to take my a sub 3.
Do I have to use the second equation, like, in order to find r? But couldn't we just use the first one?
I was saying, we are just going to use the first one.
Yeah.
I was going to say the second one only really works if we have neighboring terms, if I have pieces right next to each other. So if I have like 3, 4, and then blank, I could do that. But since we want to go between, we can't use it. So we'll use it a little bit later on with some things that we're looking at, but not tons. So I'm going to fill this in using my a sub 3 as my a sub n. And then I'm going to use my a sub 1 times r to the 3 minus 1. So I'm going to substitute this in pieces just because I know it's really easy for things to get confuddled. I only substituted in my n equals 3 and my k equals 1 here. That lets me see these pieces because I know a sub 3. A sub 3 is 4. And we know a sub 1, because that's 3. R squared. Simplifying that. Hang on a second. So these we substituted in from up here to get our 4 and our 1. So that's where those pieces came from. We substituted them in from our sequence. So dividing both sides by 3, we get our 4/3 equals r squared. Square root both sides. So, yep. 2 over root 3 equals r. What else did we forget here? Plus or minus. It could be either one. Since we are working with finding a geometric mean between them, we can just use the positive. We don't have to use the negative. Can if you want to, but you're making things harder than you need to. But we don't need to use it, but I just want us to think about that. There's options. So now we know our r is 2 over root 3. We don't like to have roots in the denominator, so what would this rationalize to?
2 root 3 over 4.
So rationalizing, because it makes my brain hurt, we'd have our r equals plus or minus 2 root 3 over 3. And again, we don't have to use both. We can just use one of them. But that lets us know our common ratio. So our last bit in here is to figure out what c is going to be. We want to find this. We know these should have a common multiple between them. Our common ratio is how it changes in between, times r. This is going to be times r. That's how it works when we're looking for our geometric sequence. That's an r we're looking at. So you can find it using the formula, or we can do this bit. I'm going to put it in the full formula just so we can see what's happening, and then we'll do a shortcut version next time. So if I want to find my a sub 2, I can take my a sub 1 times our common ratio, 2 minus 1. That's our c, which is 3 times our common ratio, which we're going to use just the positive one, 2 root 3 over 3, to the 2 minus 1.
Wait, where do we get the 2 and 1? Oh, we got
From these little guys down here. You could also do the 3 and the 2, but that would be challenging. I mean, it would be fine, but we'd wind up with a negative. So what is the value of C1 going to be?
2 root 3.
2 root 3. We took 3 times 2 root 3 over 3 to get this. So it's just like if I took this guy times r. This guy times r. If I took 2 root 3 times this again, I'd wind up at 4 again.
Wait, so then why do we use equation if we just know we're multiplying by r?
Because I wanted to see that we were multiplying it by r.
So on the test,
Either way, it's fine.
can we skip that?
Yeah.
Okay.
Yeah, I'm just showing us why it works as opposed to going, I did a magic trick and I don't know why. I was going to say, trying to call people out. I'm like, that's a very normal thing to happen. I was just to go, I did a thing, because you told me to do a thing, and I have no idea why I did the thing, but I did the thing.
That's me.
So that's why I try and work in the why we do it, so that it's easier to understand. So we can write our whole sequence now that I know all three pieces are geometric. We have our 3, 2, root 3, and then 4 is a geometric sequence. It's geometric. And again, I remember arithmetic, that's arithmetic, that's adding stuff. Geometric, we found a lot of areas in geometry, it's all multiplying. So arithmetic sequences add between, geometric sequences multiply between. Questions on this one? Because we're going to do another one that's very, very similar. Whoop, yep.
What? Hey, so
Was
what was the thing? How was the thing? And where the 3 underneath it go?
So this is the bit that's in here.
Yeah.
Hang on, changing colors. This guy is that one.
Oh.
Okay?
That I did not relate.
You did erase.
All right. So now we're going to do very similar, but we're going to find 2 geometric means between 4 and 500. So we're trying to make our geometric sequence. So I always start by writing it with our letters in between. Squiggly bracket, we're going to start at 4, bless you. We're going to put 2 geometric means in, so I'm going to call them C1 and the very highly creative C2. Oh, I know. Getting wild and crazy over here. And then 500. You can call them whatever you want. Just calling them C1 and C2 makes it easier to keep track of which one's first, which one's second. We know we have the right number. I don't care what you call them. If you call them Fred, George, and Bob, I don't care. It means the same thing. So that lets us know we have a couple of terms. We have our first term. We want to find our second term. We want to find our third term. And we also have our fourth term. So we have 4 pieces here. So we're going to use that same formula. I'm only going to write the 1 down this time. We're going to take our a sub n, bless you, with our a sub k, r to the n minus k. For our geometric sequences, that's a very important one. I'm going to make that just a little bit bigger because my n and k are very smudgy. There we go. So start by finding out what our r is. That's the first piece we need. So I'm going to take and substitute in bits. The only ones we know our numbers for are a sub 4. So I'm going to have n be 4. And our a sub 1, so I'm going to have k be 1. R to the 4 minus 1. I try not to substitute too many things in one go because honestly the place where I saw most mistakes on these kinds of problems are switching which one we have as A1 and which one is A4. So that's why I do this in a couple of steps because we need to make sure we get the 4 in place of a sub 1 and the 500 in place of the a sub 4. The most common mistake I see in these is that we switch these or we switch where the exponent is and we wind up with a -3 instead of a +3. Whoa, why is 500 tiny? Fixing that so we're at least the same scale. But that's going to equal our 4 times r to the 4 minus 1. 4 minus 1 gives us 3. So what do we do to figure out what r is?
Divide by 4.
Yep.
Take the with me plus or minus 1 to the bottom. It's going to be positive, right?
I was going to say, with cubes, do we want to put the plus or minus?
No, you don't.
Because it's a cube, so we're only going to have one answer. So what is our r going to be? 5. So we know that between each of these pieces, it's supposed to multiply by 5.
4 root 3 root the you know what it is? Yeah.
Ooh.
What is it called? The thing?
Do we have a root in our R?
Cube root.
Oh, okay. To get from the 125.
I did this wrong.
No, because I'm looking at things that's 500.
Oh my. I did all this wrong. I'm so sorry, guys.
I was gonna be like, we shouldn't need a root on it.
I thought so.
So 20 and
Mm-hmm. Yeah, we can find our next terms by taking that. What is up with that C? That C looks weird. We can take the previous term, so I can grab my 4 and multiply it by that common ratio to find that our first arithmetic mean, or geometric mean, is 20. And then our next geometric mean is going to be taking that 20 again times the 5, which is the 100. So our full geometric sequence is 4, and then 20, and then 100, and then 500.
keep that for your home.
Turn me a sweet girl.
All right, we're going to do one more like this, and then we'll move on to the next bit. Okay? So we've done inserting 1 geometric mean. We're going to do 2 geometric means. Let's do a little bit more. We're going to do 4 geometric means between 48 and 3/2. 4.
We need a line for 70.
Oh, what? I'm so sorry.
So I'm gonna go down.
Mm-hmm.
Bro, that's not fair. You gave me less.
Okay, so we just follow like the order that the terms are given.
Yes.
I'll quit asking questions.
Oh.
Whoa.
Aggressive. So our terms are given to us with 48 as the first term, and then we want 1, 2, 3, 4 means in between. And then we should get to 3/2. So give this a shot. See what we can come up with for our common ratio. What do we get as what's happening between them?
Sorry, doesn't know how to. It's because I can't say 48. Oh my gosh. Times R of 6 minus. Oh my gosh.
We divide by 3. I don't know how to do that. So we're going to multiply.
My calculator's gonna do it.
It's like do it in 2 steps.
Are we supposed to get like 0.0 something?
We might at one point.
At one point?
I was gonna say that should not be our final
No,
answer.
yeah.
Yeah,
Okay.
it is gonna be decimally or fractionally, depending on how you view it.
Whoa, that is not correct.
I got 1/2.
By the very, very end, you should get to 1/2
For ours?
for our R.
Take a fifth root of 1 over 32.
Mhm. So let's look at this. I'll
What in the world?
A1 times R to the 6 minus 1. So substituting our pieces in.
I think we're wrong.
Wait,
So
how do
we
you divide
have-
by a fraction? Do you just...
Reciprocal multiple times.
Multiply by the reciprocal or multiply by your denominator, and that'll get rid of the fraction part. Multiply both sides. Let's look at it then. So then we've got our 48 times R to the 5th.
We have no calculator test.
I believe there are some no calculator tests.
Oh.
So when in doubt with something like this, feel free to multiply by your denominator on both sides. And that'll then let you divide by your coefficient. So if you want to do it that way, totally valid, where we're going to have our 3 equals
Did not get 1/2.
96 R to the 5th. Totally valid to go here to kind of get yourself situated so we know what's happening. Multiplying both sides by 2. then it's a little easier to see what's going on with trying to get r by itself. So, bless you. We get 3 over 96 equals r to the 5th. 3 over 96, it simplifies. That's the same thing as 1 over 32. So then if we take our 5th root of both sides, I'm just going to scooch. So this is this, what? Not the thing. No. So this is the same thing as 1 over 32. So if we take our 5th root, we actually get the 5th root of 32 is 2. So 1/2 equals r. So we know our common ratio. Every single time between these pieces, it's multiplying by 1/2.
And then we just multiply. So 48, 24, 12, 6, 3.
And then we wind up at 3/2. We wind up exactly where the next piece is.
1.5.
So finding our pieces, our a sub 2, we get from taking our 48 times that common ratio times our 1/2, and we get 24. And we get 24 times 1/2. So we get 12, and then we'll have our A3, which is 6. Oh, except I've unnumbered properly. That one was 3. This one was 4. There we go. A sub 5, which is 3. And then if I kept going and I did one more, we'd wind up with 3 over 2, because 3 times 1/2 is 3/2, which is exactly where we wound up. So our geometric sequence, we'd have our 48, and then our 24, and then our 12, and our 6, and our 3, and our 3/2. Okay, so we've looked at our geometric sequences and our geometric means, just like we did our arithmetic sequences and our arithmetic means. The one thing we did with our arithmetic stuff that we haven't done with our geometric stuff is our sums. So we're going to do sums of our geometric sequences.
No.
Yes. Very much like our sigma stuff. These guys, where we're adding up all of our pieces. So this is an important formula for us. We can find our sum of n terms, so from 1 to n, if we know our first term times this hot mess. R is our common ratio, so how it's changing between each piece. And n is our number of terms. So r gets used twice in that fraction. N is a power in that fraction. N is the number of terms that we're adding together. So write this down. This is a really important piece for us. Because what we're going to do first is I'm going to give us a sequence, and we're going to find the sum of the first few terms. So here's a sequence.
I'm good.
And we're going to find the first 5 terms to find the sum. This is our sequence. We have 4. So that is absolutely one option, is to define the next piece and brute force it. So this guy is our first term. We've got our second term. This is our third term. This is our fourth term.
Wouldn't it be like a 0.081? Should say like.
Oh, yes. Yeah, you're just jumping ahead of me, but yes.
No, you're wrong. No.
So we want to find the sum of the first 5 terms. So I could just figure out what A5 is, brute force, add them together. Totally valid. No matter what we're doing, I need to know my common ratio. We need to know how it's changing between them. This time we could use that common ratio formula that we had that I put up on that very first page. We were doing our common ratio we get from doing a sub k plus 1 over a sub k. Oop, that's definitely meant to be lower. This only works when they're sequential. We have to find a 5. It's not there. We want to find our first sum of the first 5 terms. So we could find our R. I know sequential terms. I know A1 and A2. So I could put A2 over A1. I could put A3 over A2, A4 over A3. As long as I have 2 neighboring pieces, we can do that. So if I take our 0.3, our A sub 2, over our A sub 1, what's our common ratio? 0.3 or 3/10, either way. I do not care if you do it decimally or fractionally. I don't care. So we could find a 5 by finding our next piece. That's option 1. What do you mean? Yes, that would be option 2. I'm going to do both. So what would our A sub 5 be? What is
0.0081.
Because we take our 0.027 times our common ratio of 0.3. So we would get that our A sub 5 is our 0.0081. So I could find the sum from 1 to 5 of our sequence by adding them up. 1 plus 0.3 plus 0.09 plus 0.027 plus, lots of zeros, 0.0081. Well, that's the first. That's it, because we have our 1, 2, 3, 4, 5 terms. That's what we wanted. From our first term to our 5th term. What do we get when we add those all up? Don't round it. That's not what I have. Yeah. 4, 2, 5, 1. Should be what we have.
Why are they both the same?
Oh my gosh, I don't think there's 2 different ways of doing the exact same thing. What? So let's try it with our formula here and see what's going on. So if I wanted to find my sum of those 5 terms, we can do so using this formula. We take our first term. We know our A sub 1. That's our 1. And then we're going to multiply by this fraction. We're going to have 1 minus our 0.3. That's going to get raised to the power 5. And in our denominator, we're going to have our 1 minus our 0.3. So we can do this in the calculator, and we're going to make it be decimals because then it's a little bit less gross. That 1 times just kind of disappears. It absorbs in. So our 1 minus 0.3 to the 5th. 0.3 to the 5th is 0.00243. So if I take 1 minus 0.00243, we get 0.99757. And if I do 1 minus 0.3, we get 0.7. Like, that looks weird, but okay. 0.7. And if we divide those, since, you know, we use calculators anyway, 0.99753 divided by 0.7, we get exactly 1.4251. And then I don't have to sit here and type in all these gabillions of decimals. We type these into the calculator and let it do the work. A lot less typing on this than on this. Okay, so it's two different ways of getting to that same exact answer. We can brute force and add it together. There's only 5 terms. That's fine. But if I was asking you for the sum of the 50 terms, ew. I don't want to have to add 50 things. Gross. I don't even have to do 10 things. Gross. That's a lot of typing. So eventually the calculators do run out of characters. They'll let us put a whole bunch in, but they do eventually stop letting us type things in. So we don't want to have to add in manually if we were finding the sum of the first 50 terms of the sequence. I'd like to be able to type it in the calculator because that's way less gross. So questions on our first sum here. So then let's look at the next one. The other way they like to give us this kind of problem is to give us a term, give us the common ratio, and what our n's going to be. So we're given that our a sub 4 is 27, our common ratio is 1/3, and we're asked to find sum of the first 7 terms. So we're given that our n is 7. So I have a lot of pieces over here. If we look at our little formula, I know that we're going to do our s sub 7, because they've told us that our n is going to be 7. Oop, that's not one. We need to get our a sub 1 over here. 1 minus our r, we know that is our 1/3. That's this guy. There we go. Our 1/3. I'll put it down here as well. To the 7th over our 1 minus our 1/3. We didn't use our a sub 4 at all, and we're still missing our a sub 1. The heck do we do?
Didn't you use the A4 within the R to find?
We are going to use our formula we've used already a couple times today to be able to find a sub 1.
So A1 equals A4.
Mm-hmm.
Well, 27 times 1. And then to the power of 1 times 4.
And it's going to be a power of 1 minus the 4. So we're trying to find a sub 1. That's our guy we want to have. Our a sub 1 is what we're looking for. But we're going to get that from the fact that our a sub 4 is 27. Yes, you're jumping ahead of me. But yes, our 1/3 to the negative 3rd.
Wait, is it okay if we just multiply, work my a sub 4, we just multiply by 3 times? The a sub 4?
As long as, yes, because that negative in our exponent's going to make that flip up to be a 3 anyway, so it's going to be 27 times 3 to the 3rd. So it's doing the same thing, as long as you're aware of what the process is, that we're multiplying backwards because we're dividing. Works for me. So our first term, our a sub 1, is going to be 729. So that lets us come over here to our sum formula, substitute that guy in, and I don't have to find my first 7 terms. I can just go over here. What's up?
That's 27 times 27.
Correct. So we can find our sum by putting our 729 times this fraction with our 1 minus 1/3 to the 7th and 1 minus 1/3. So we're going to have our 729 times our fraction. And if it helps to do this in pieces, that's totally fine. We can do our 1 minus, we can do our 1/3 to the 7th. gonna give us 1 over 2,187. So our numerator in this case would be 2,186 over 2,187, because 1 minus. And then we'll have our 1 minus 1/3, also known as 2/3, down here. But you can put it into your calculator just like this. You can do fractions inside the fractions. What are we going to get as our sum of these first 7 terms? 1093. Okay. We're going to go ahead and end it right there. We have one more concept to go. And that'll be kind of it. So we're going to work on that tomorrow. We should be able to finish it up.
That's Friday.
Test is Friday.
The final. Well, you know math is always going to have. Is that the final review?
No. So I do have, if you're interested in it, already the chapter review for this chapter test. It's coming up on Friday. I'll put it out on the little table right by the door because we only have like, we got 3 minutes till pass them out. Because I'm like, I don't want to like rush these kids, but yeah. So this is the chapter review for the chapter test coming up on Friday.
Have you gotten the final yet?
I have gotten the final. I'm working on getting our final review and all the things put together for it.
Is it harder than like what you
It's about on par with
see? Is it?
We'll be all right.
Cheek, cheek.
What's up?
They need to give us a VP.
I
They're
will fight. We'll see. We'll see.
Oh.
Working on.
This is like a small things part, at least.
Working on. We'll see.